Throughout history, humanity has looked to the heavens in awe and wonder. The night sky, with its myriad of stars, planets, and other celestial phenomena, has always been a source of fascination and inspiration. From the earliest days of human civilization, people have gazed up at the stars, seeking to understand their place in the universe and to find meaning in the patterns they observed. The heavens have been a canvas for our myths, legends, and even our hopes and fears. The stars have served as both a source of navigation and a canvas for our myths and legends. Ancient mariners used the stars to guide their voyages across vast oceans, while farmers relied on celestial cycles to determine the best times for planting and harvesting. Constellations, those familiar patterns in the night sky, have been named after gods, heroes, and mythical creatures, each with its own story to tell. These stories have been passed down through generations, weaving a rich tapestry of cultural heritage. But what happens when these celestial wanderers move from the realm of myth to the realm of potential threat? Comets, meteors, and asteroids, once seen as omens or divine messengers, are now understood to be natural objects with the potential to impact our planet. The transition from myth to science has not diminished their significance. Rather, it has heightened our awareness of the dynamic and sometimes perilous nature of the cosmos. What happens when ancient prophecies seem to align with modern scientific discoveries? Throughout history, many cultures have recorded prophecies and predictions about celestial events. These prophecies, often steeped in religious and mythological traditions, have described stars falling from the sky, fiery comets, and other dramatic celestial phenomena. Today, scientists with advanced telescopes and space missions are discovering that some of these ancient predictions may have been based on real astronomical events. For millennia, cultures across the globe have recorded prophecies of celestial events impacting life on Earth. These records, found in ancient manuscripts, cave paintings, and oral traditions, reflect a deep-seated human fascination with the heavens. From the Mayans and the Chinese to the Greeks and the Egyptians, civilizations have meticulously documented the movements of celestial bodies and interpreted their significance. These records provide a valuable historical context for our modern understanding of astronomy. Many of these prophecies, steeped in religious and mythological traditions, speak of stars falling from the sky, fiery comets, and celestial objects wreaking havoc on our planet. These vivid descriptions have captured the human imagination for centuries, inspiring both awe and fear. While some viewed these events as divine retribution or omens of change, others saw them as natural phenomena to be studied and understood. The idea of celestial objects wreaking havoc on our planet has been a recurring theme in human history. Apocalyptic imagery depicting comets and meteors crashing into Earth has been found in various cultures' art and literature. These depictions often symbolize chaos, destruction, and the end of an era. However, they also serve as a reminder of the fragility of our existence and the need to be vigilant in understanding the forces that shape our world. For centuries, these prophecies were often dismissed as allegory or superstition. Skeptics argued that they were merely the products of overactive imaginations or attempts to explain natural phenomena without the benefit of scientific knowledge. However, as our understanding of the universe has grown, we have begun to see that there may be more to these ancient stories than we once thought. The line between myth and reality is not always as clear as it seems. However, with the advent of modern astronomy and our growing understanding of the cosmos, we've begun to recognize the very real threat posed by near-Earth objects. Advances in technology have allowed us to detect and track these objects with unprecedented accuracy. Scientists now use powerful telescopes, satellites, and computer models to monitor the skies and predict potential impacts. This knowledge has transformed our approach to planetary defense, making it possible to take proactive measures to protect our planet. The universe is a dynamic and ever-changing place. Stars are born and die, galaxies collide, and celestial objects travel through space on unpredictable paths. This constant motion and change are what make the study of astronomy so fascinating. It reminds us that we are part of a much larger cosmic story, one that is still being written. Asteroids and comets, remnants from the early solar system, hurtle through space, their paths occasionally intersecting with our own. These ancient objects are like time capsules, preserving clues about the conditions and processes that shaped our solar system billions of years ago. By studying them, we can learn more about the origins of our planet and the potential threats that lie beyond our atmosphere. While most of these objects pose no threat, some have the potential to cause significant damage, even triggering catastrophic events. The impact of a large asteroid or comet could result in widespread destruction, climate change, and mass extinctions. Understanding these risks is crucial for developing strategies to mitigate them and ensure the long-term survival of life on Earth. The possibility of a major impact, once relegated to the realm of science fiction, is now a scientific reality. Movies and books have long depicted dramatic scenarios of asteroid impacts and their aftermath, but today, scientists are taking these threats seriously. Research and international collaboration are focused on finding ways to detect, track, and potentially deflect hazardous objects before they can cause harm. This realization has led to a renewed interest in not only understanding these celestial objects, but also in developing ways to detect and potentially deflect them. Space agencies around the world are investing in missions to study asteroids and comets up close, testing new technologies for planetary defense. The goal is to ensure that we are prepared to respond to any potential threats from space, safeguarding our planet for future generations. In December 2009, NASA embarked on a groundbreaking mission by launching the Wide Field Infrared Survey Explorer, or WISE. This space telescope was meticulously designed to map the entire sky in infrared light, a spectrum invisible to the human eye but crucial for uncovering the hidden secrets of the universe. WISE's mission was ambitious and multifaceted. It aimed to uncover hidden objects in our solar system, study distant galaxies, and provide a deeper understanding of the formation of stars and planets. By capturing images in infrared light, WISE could see through cosmic dust clouds that often obscure these celestial bodies in visible light. The telescope's infrared capabilities allowed it to detect objects that were otherwise invisible, such as cool stars, asteroids, and even brown dwarfs. WISE's mission was to uncover hidden objects in our solar system, study distant galaxies, and learn more about the formation of stars and planets. This comprehensive survey provided astronomers with a treasure trove of data, enabling them to make groundbreaking discoveries. One of the most significant contributions of WISE was its ability to study the formation of stars and planets. By observing the infrared light emitted by these objects, scientists could gain insights into the processes that govern their birth and evolution. This knowledge is essential for understanding the origins of our own solar system and the potential for life elsewhere in the universe. WISE excelled in its mission, capturing stunning images of the cosmos that revealed the beauty and complexity of the universe. These images not only captivated the public's imagination, but also provided invaluable data to astronomers worldwide. The telescope's observations have led to the discovery of thousands of new objects, including previously unknown asteroids and distant galaxies. The data collected by WISE has been instrumental in advancing our understanding of the universe. Astronomers around the globe have used this information to conduct research, develop new theories, and make groundbreaking discoveries. The telescope's contributions to the field of astronomy cannot be overstated. After successfully completing its primary mission, WISE was placed into hibernation in 2011. However, the telescope remained a valuable asset, its infrared capabilities perfectly suited for detecting the heat signatures of near-Earth objects. Recognizing the potential of WISE's infrared technology, NASA decided to repurpose the telescope for a new mission. In 2013, WISE was reactivated with a new mission to identify and characterize potentially hazardous asteroids and comets. This decision marked the beginning of a new chapter in the telescope's legacy. The reactivated telescope, now known as NEOWISE, Near-Earth Object Wide Field Infrared Survey Explorer, was tasked with safeguarding our planet by detecting and tracking near-Earth objects. Its infrared vision allows it to detect the faint heat signatures of objects that are difficult or impossible to see with visible light telescopes. NEOWISE's mission is critical for planetary defense. By identifying potentially hazardous asteroids and comets, the telescope helps scientists assess the threat they pose to Earth and develop strategies to mitigate potential impacts. This proactive approach is essential for protecting our planet from cosmic hazards. Reborn as NEOWISE, the telescope embarked on a new chapter, its gaze fixed on safeguarding our planet. This transformation represents a remarkable example of repurposing space technology for a new and critical mission. NEOWISE's contributions to planetary defense are invaluable, Its ability to detect and track near-Earth objects provides scientists with the information they need to protect our planet. This mission underscores the importance of continued investment in space technology and research. NEOWISE represents a remarkable example of repurposing space technology for a new and critical mission. Its success demonstrates the potential for innovative solutions to address emerging challenges in space exploration and planetary defense. Its infrared vision allows it to detect the faint heat signatures of objects that are difficult or impossible to see with visible light telescopes. This capability is crucial for identifying and tracking near-Earth objects, which can pose a threat to our planet. This makes NEOWISE an invaluable tool in our ongoing efforts to catalog and track near-Earth objects. By providing accurate and timely data, the telescope helps scientists monitor the skies and ensure the safety of our planet. The legacy of WISE and NEOWISE continues to inspire and drive advancements in space exploration and planetary defense. NEOWISE plays a crucial role in planetary defense. This space telescope, launched by NASA, is specifically designed to detect and track near-Earth objects, or NEOs, which include asteroids and comets that come close to our planet. Its mission is vital for identifying potential threats and ensuring the safety of Earth. By scanning the skies in infrared light, it detects the heat emitted by asteroids and comets, which allows it to spot objects that might be missed by other telescopes. Infrared detection is particularly useful because it can reveal objects that are too dark or too small to be seen in visible light, even those that are too dark or too small to be seen by other telescopes. This capability is crucial because many potentially hazardous objects are not easily visible with traditional optical telescopes. NEOWISE's ability to detect these hidden threats makes it an indispensable tool in our planetary defense arsenal. This data allows scientists to determine the size, composition, and trajectory of these objects, providing a comprehensive understanding of their characteristics. By analyzing this information, researchers can predict the paths of these objects and assess their potential impact on Earth, helping us assess the potential risk they pose to Earth. Understanding the trajectories and physical properties of NEOs is essential for developing strategies to mitigate any potential threats. This knowledge enables scientists to devise plans to deflect or destroy objects that might collide with our planet. Near-Earth objects are classified based on their size, orbit, and potential to make close approaches to Earth. These classifications help scientists prioritize which objects to monitor more closely and which ones pose the greatest risk. Objects that come within a certain distance of Earth's orbit are classified as potentially hazardous asteroids, or PHAs. These are the objects that require the most attention because of their potential to cause significant damage if they were to impact Earth. NEOWISE's observations are essential for identifying and characterizing these PHAs, providing detailed information about their orbits and physical properties. This data is crucial for developing effective planetary defense strategies, providing crucial data to assess and mitigate potential threats. By continuously monitoring the skies, NEOWISE helps ensure that we are prepared to respond to any potential danger from space. The information gathered by NEOWISE is not just about cataloging potential threats, it also contributes to our broader understanding of the solar system. The data collected by NEOWISE helps scientists study the distribution and characteristics of asteroids and comets throughout the solar system. It's also about understanding the origins of our solar system. By studying these ancient objects, scientists can gain insights into the conditions and processes that existed during the early formation of the solar system. Asteroids and comets are remnants from the early formation of our planetary system, and they hold valuable clues about the materials and conditions that led to the creation of planets. And studying them provides valuable insights into the processes that led to the creation of Earth and our neighboring planets. This research not only helps us understand our own origins, but also informs our search for life and habitable environments beyond our solar system. Since its reactivation, NEOWISE has made significant contributions to our understanding of God's creation of the universe. It has discovered thousands of previously unknown asteroids and comets, greatly expanding our catalog of these celestial wanderers. NEOWISE's data has also helped refine the orbits of known objects, improving our ability to predict their future trajectories. One of NEOWISE's key achievements has been its ability to identify and characterize potentially hazardous asteroids. By studying the infrared light emitted by these objects, NEOWISE can determine their size, composition, and reflectivity. This information is crucial for assessing the potential risk they pose to Earth and developing strategies for mitigating that risk. NEOWISE's observations have also led to a better understanding of the composition of asteroids and comets. By analyzing the infrared light they emit, scientists can determine the presence of water ice, organic molecules, and other materials. This information provides clues about the conditions that existed in the early solar system and the processes that led to God's divine formation of planets and other celestial bodies.